Okay, so here I'm recording a solution to question 4 on 20.1. Okay, so question 4 here. A hand pump was used to raise the pressure. So here we've got the flask, and the flask has a volume, let's call that VF. So VF equals 1.2 times 10 to the minus 4 meters cubed, and that's connected to a hand pump, which we're not told the volume of, so let's call that Vx. Okay, and we're told here that without any power, the pressure increased from P1 was 110 kilopascals, and P2, the final pressure, was 135 kilopascals. And then we have some sort of powder in it. Well, part A doesn't ask about powder. So initially, for this one here, demonstrate that the volume of air in a hand pump initially was 2.7 times 10 to the minus 5 meters cubed. Okay, so our P1, we know, was 110 kilopascals. P2 is 135 kilopascals. Our initial volume, V1, equals the volume of the flask plus the volume of the hand pump. And when that's pumped down, well, assuming this pipe has no volume, then we've got just the volume of the flask. So V2 equals the volume of the flask. So we apply the volume pressure times volume, as long as we keep the mass of air constant, before equals a constant, so equals the after. Then the thing I'm trying to work out is going to come from here, but I'll do that in a moment. So here we've got pressure 1 is 110 kilopascals. The initial volume is VF, which is 1.2 times 10 to the minus 4 plus Vx, the thing I'm going to try and work out, and pressure 2 is 135 kilopascals, and that's multiplied by 1.2 times 10 to the minus 4, the volume we have there. So kilopascals is going to multiply into everything, so I just cross that out, that's fine. So looking over here, we've got 110 times 1.2 times 10 to the minus 4 plus 110 Vx, and that equals 135 times 1.2 times 10 to the minus 4. Bring them all onto one side. We've got 110 Vx equals 135 times 1.2 times 10 to the minus 4 minus 110 times 1.2 times 10 to the minus 4. Well, before I go to my calculator, I've got a common factor there. So let's just take out 1.2 times 10 to the minus 4, and we've got 135 minus 110. So that's 25 over there. Okay, we're doing that. And that equals 110 Vx. Vx equals 25 times 1.2 times 10 to the minus 4 divided by 110. So that equals 25 times 1.2 exponent minus 4 divided by 110, 2.73 times 10 to the minus 5 meters cubed, which is what they had there, 2.7. Good. Okay, part B. Calculate the volume and the density of the powder. So in this case, we've now got here a powder here, and that's occupying, let's call that volume VP, volume of the powder. So now that no air can go into that volume. So what we need to do here is our new V1 equals the volume of the flask, VF, minus the volume of the powder, and our new V2, plus the volume of the hand pump, which I forgot to put in here. Okay, our new V2 is going to be volume of the flask minus VP. Okay, and our P1 equals still 110 kilopascals, and our P2 equals now 141 kilopascals. Okay, so the first thing I need to do is I can work out this volume now, because I think that's the only unknown I've got here. So again, doing P1 V1 equals P2 V2. My initial pressure is 110 kilopascals. My initial volume is VF. I'll just do them all together. So VF plus VX. So we've got 1.2 times 10 to the minus 4 plus VX, which I worked out here, 2.7 times 10 to the minus 5. Okay, and that's going to be taking away this thing, I don't know, VP. And that's going to equal my new pressure, 141 kilopascals, multiplied by the volume of the flask, 1.2 times 10 to the minus 4, minus this unknown VP. Okay, so let's sort out what we can do. So this bit here, we've got 110 times 1.2 exponent minus 4 plus 2.7 exponent minus 5. So that's 0.01617 minus 110 VP, and that equals here 141 times 1.2, we should put them together but I didn't, 0.01692 minus 141 VP. So put them together, going to add them, take away over there. Yeah. Okay, so let's bring this one over here. So 141, so that's going to give us on this side 31 VP equals, by adding it onto that, and then over here, bring that over there, we got 0.01692 minus 0.01617. So that equals 0.00075 meters cubed. So the volume of the powder is 0.00075 divided by 31. The volume of the powder equals 2.42 times 10 to the minus 5 meters cubed. They've told me that the mass of the powder is 0.038 kilograms. Density equals mass over volume, so the density equals 0.038 kilograms over 2.42 times 10 to the minus 5 meters cubed, and that equals 0.038 divided by that one equals a density of 1,571 kilograms per meters cubed, which hopefully is right.